Hi, let us see how to obtain singular value decomposition of a matrix. So given a matrix, either it is a square matrix or a rectangular matrix, we'd like to express this matrix into this form, U into sigma into V transpose, where sigma is a matrix of same size as A and which contains only the diagonal entries, where the diagonal entries are going to be square root of eigenvalues of A into A transpose. And when this U is a matrix which contains eigenvectors of A into A transpose, whereas V is a matrix obtained from eigenvectors of A transpose into A. Okay, so let us try to look at an example to understand this. So here we need to compute eigenvectors of this, singular value decomposition of this matrix. So first, what do? You start with A into A transpose, find its eigenvalues, eigenvectors, then you write the matrix U. Then you find A transpose into A, and then you find its eigenvectors and eigenvalues and eigenvectors, then you write the matrix V. So from that we can get SVD. So only two steps. So first let me write what is A into A transpose, so which is 3 1 1 negative 1 3 1 multiplied with 3 1 negative 1 and 1 1 3 1. You can see that this product is 11 and next one and 11. Let's see eigenvalues of this matrix, that is A into A transpose minus lambda times of identity. Let's equate its determinant to 0. So this is the characteristic equation. Now lambda square minus, you know what is the trace of this matrix? Trace is 22 into lambda plus determinant of this matrix. This is 121 minus 1, that is 120 equal to 0. And this matrix can be factorized, this equation can be factorized into lambda minus 12 times lambda minus 10 equal to 0. Therefore the eigenvectors are lambda equal to 12 and lambda equal to 10. These are the eigenvectors. Now let us find the corresponding these are the eigenvalues. Let us find the corresponding eigenvectors. Well, lambda equal to 12, let me see what is A into A transpose minus 12 times of identity. This multiplied with x equal to 0. This implies A transpose minus 12, 11 minus 12, that is negative 1, 1, 1, 11 minus 12, negative 1. This multiplied with x, y, which is equal to 0, 0. And we have only one equation, this is negative x plus y equal to 0. From this, y must be equal to x. Therefore, the eigenvector, so when x is 1, y must be 1. So this is the eigenvector. But what I need is unit eigenvector. So therefore, unit eigenvector, that's nothing but the length of this guy is root 2, so 1 by root 2, 1 by root 2. So for lambda equal to 12, we are done with it. Next, let us find the eigenvector for lambda equal to 10. So we need to solve this equation, that is A into A transpose minus 10 times of identity multiplied with x equal to 0. You can easily see what it is. 11 minus 10, that is 1, 1, 1, 11 minus 10, 1. This multiplied with xy equal to 0. This implies there is only one equation, this is x plus y equal to 0. So from this, y must be equal to negative x. Okay, so therefore the eigenvector, which is nothing but when x is 1, y must be negative 1. But we want the unit eigenvector, so unit eigenvector is 1 by root 2, negative 1 by root 2. Why? Because its length is root 2. Okay. Now we can write the matrix U. Now the matrix U, so the first column is eigenvector for root 12, which is 1 by root 2, 1 by root 2, and the second column is nothing but eigenvector of 10, which is 1 by root 2, negative 1 by root 2. Alright, we are done with finding u. Next, let us go for v. It means now I need to look for A transpose into A. You know what is A? A is actually 3 1 1 negative 1 3 1, and now you write its transpose 3 1 1 negative 1 3 1. Now I need to calculate this product. So the product is 3 times the first column, negative 1 times the second column. This gives me 10, 3 minus 3 0, 3 minus 1 2. The next, 1 times the first column, 3 times the second column, 0 here, 10 here, whereas 1 plus 3, which is 4. And the next, sum of these two columns, 1 times first column plus 1 times the second column. So this is 2 4 2. So this is what A transpose into A. Now we need to find eigenvalues of A transpose into A. So for that, let me write the characteristic equation. Determinant of A transpose A minus lambda times identity equal to 0. See, definitely whatever eigenvalues you got it here, that are 10 and 12, you're going to have it here, the same eigenvalues. But you may have one more eigenvalue extra, that is what, 0. Okay, let me write the characteristic equation. This is lambda cube minus trace of A into lambda square plus sum of the cofactors of the diagonal entries into lambda minus determinant of A equal to, determinant of A transpose into A. So this is actually supposed to be A transpose into A. Okay, so I should write it A transpose into A equal to 0. So this is lambda cube minus trace is 22 lambda square plus sum of the cofactors. For 10 it is 20 minus 16, this is 4, plus next for this 20 minus 4, which is 16, plus next for 2 it is 100 into lambda. Now the determinant of the matrix is 0. Why? Because rank of A transpose is a 2 by 3 matrix, and A transpose is a 3 by 2 matrix, A is a 2 by 3 matrix. So when you take the product, so you will get a matrix of rank less than or equal to 2 only. Okay, so now this matrix, this product matrix will be a matrix of rank less than or equal to 2. So its rank cannot be equal to 3. So when the rank is not 3, then definitely its determinant is 0. It's a 3 by 3 matrix and its rank is not 3, definitely determinant is 0. Otherwise you just compute it, you can find it is 0. Okay. Now I can take lambda common, so I get lambda square minus 22 lambda plus 120 equal to 0. So from this you can see what are the eigenvalues: lambda equal to 0, lambda equal to 12, and lambda equal to 10. So these are the eigenvalues. Now we have to find the corresponding eigenvectors. So first let me start with lambda equal to 12. When lambda equal to 12, let me see what is the eigenvector. So it means I need to see A transpose A minus 12 times of identity multiplied with x equal to 0. So this is what, what is A transpose A? This is what. So 10 minus 12 will give me negative 2. So negative 2, and this is 0. Am I correct? Yeah. 2. And this is 0, negative 2, 4, and this is 2 4. This is actually 2 minus 12, which is negative 10. X, y, z, this is equal to 0 0 0. So this implies, if you solve these equations, negative 2x plus 2z equal to 0. And from this you can see what is z. Z is nothing but x, or x equal to z. And from the next equation, 2x plus 4z, this is actually 2y. Negative 2y plus 4z equal to 0. From this you can see what is z. Z equal to 2z equal to negative y. or in other words y equal to not negative, this is 2z. No need of solving this next equation because the next equation will be combination of first two. So from this, therefore the eigenvector, so eigenvector for lambda equal to 12, that is when, okay, let me take z equal to 1. When z is 1, definitely x is 1, y is 2. Okay, but we want a unit eigenvector, so its length is nothing but root 5. So 1 by root 5, oh sorry, root 6. Why? Because 1 plus 4 plus 1, root 6. So 2 by root 6, 1 by root 6. So this is the eigenvector for lambda equal to 12. Next, let me see what is the eigenvector for lambda equal to 10. Okay, so now I need to write this guy, that is A transpose A minus 10 times identity multiplied with x equal to 0. So this implies, let me write this system here, 10 minus 10, 0, 0, 2, and this is 0, 10 minus 10, 0, 4, and I hope it is 2 here, 4 here, and 2 minus 10, negative 8, multiplied with x, y, z, that's equal to 0, 0, 0. Okay. Now you can see from the first two equations 2z equal to 0, that implies z equal to 0. Okay, and from the last equation you can see 2x plus 4y plus, sorry, 4y minus 8z equal to 0. From this, you know, z is anyway 0. When z is 0, you have 2x plus 4y equal to 0. Now this implies, you can see y equal to negative 2y. Okay, so y equal to negative 2y, or in other words you can write, sorry, x equal to negative 2y. So in other words, y equal to, what is it, negative x by 2. Okay, so now let us write what is the eigenvector. So now eigenvector, which is nothing but so let me take x equal to 2. So in that case I get negative 1 here, then I get what, I'd like to take x is negative, x is 2. If I take x to be 2, then y will be negative 1, z is anyway 0. Okay, now what is the unit eigenvector? So unit eigenvector is nothing but, the length of this is 4 plus 1, 5, so 1 by root 5, so therefore 2 by root 5, negative 1 by root 5, 0. So this is the unit eigenvector. Next we need to find eigenvector for lambda equal to 0. So when for lambda equal to 0, A transpose into A minus 0 times of identity multiplied with x equal to 0, this implies, what is A transpose into A? We know that is 10, 0, 2, 0, 2, 0, 10, what is it? Remember 2 here, 4 here, and this will be 4, whereas this one will be 2. This multiplied with x, y, z equal to 0, 0, 0. Let me check whether I wrote correct or not. A transpose into A. Yeah, correct. Now the equations are 10x plus 2z equal to 0. From this, z is nothing but negative 5x. And from the second equation, 10y plus 4z equal to 0. This implies z equal to z equal to, what is it, negative 5y by 2. Let me do one thing. Let me express x in terms of z. That is better. X will be negative z by 5, negative z by 5, and y will be negative 2z by 5. So therefore the eigenvector, so let me take z equal to 5. That would be better. If I take z equal to 5, then x will be negative 1, y will be negative 2. Okay, so this is the eigenvector for lambda equal to 0. Now the unit eigenvector, which is nothing but the length of this is 1 plus 4 plus 25, that is 30. So negative 1 by root 30, and negative 2 by root 30, and 5 by root 30. Yes. So from this you can write what is v1, what is v. V is nothing but, let me say, v1, v2, v3, where this is v3 and this is v1 for lambda equal to 12, whereas for lambda equal to 10, let me assume this is v2. Okay, now let us write the singular value decomposition of A. Therefore A equal to u into sigma into v transpose. Okay, this is A equal to, we already write u. Do you remember where is u? Here, 1 by root 12, 1 by root 12, and this, sorry, is that 12? That is 2, not 12. So 1 by root 2, 1 by root 2, and 1 by root 2, negative 1 by root 2. Okay, and remember this sigma is a matrix of same size as A. A is a 2 by 3 matrix. So here I should have a 2 by 3 matrix only. So the first entry will be the eigenvalue corresponding to this eigenvector. So we know that is 12, but here you should take square root. So square root of the eigenvalue of this column. 0, next 0, and what is the eigenvalue corresponding to this column, which is 10. Now you take its square root. So the singular values of A are root 12 and root 10, and the next column will be 0, 0. This multiplied with V. We know what are the columns of V. So the first column is V1. Where is it? Here, 1, 2, 1. Let me write. So 1, 2, 1. We know its length is root 6. And the second column, of the matrix, which is 2, negative 1, 0. So 2, negative 1, 0. And the last column, which is negative 1, negative 2, 5. So negative 1, negative 2, and 5. So this is the matrix V, but we should take the V transpose. Okay, now A can be decomposed into this form, U sigma V transpose, where U and V are orthogonal matrices. You can verify that. And suppose if you are asked to verify the singular value decomposition, so let's do the verification part. It means when you multiply these three, you should get back to A. Let me see whether I'm getting back to A or not. So first I'll do one thing, I'll multiply these two. Okay, so root 12 into the first column plus 0 into the second column. So root 12 into the first column will be root 6, root 6. Next, the second column of the matrix is 0 times the first column plus root 10 into the second column here. So that is root 10 by root 12, root 2, which will be root 5, and negative root 5. Next, the third column, 0 times the first column plus 0 times the second column, 0, 0. And let me write what is V transpose here. V transpose is 1 by root 6, 2 by root 6, and 1 by root 6, and this will be 2 by root 5, negative 1 by root 5, and 0, negative 1 by root 30, and negative 2 by root 30, 5 by root 30. So when you multiply, so the first row, let me write what is the first row. Root 6 times the first row here, plus root 5 times the second row here, plus 0 times the third row. So now the entries in the first row, you just need to add 1 plus 2 plus 0, that is 3. 2 minus 1 plus 0, that is 1. 1 plus 0 plus 5, that is 1. So that is the first row. Next, the second row, root 6 into the first row, negative 5 into the second row, plus 0 into the third row. So 1 minus 2, negative 1. 2 minus of minus, it will be plus 3. 1, anyway it is 0, so 1. So this is what exactly A is. So whatever decomposition we did, which is correct. So A equal to U sigma V transpose. And this is the singular value decomposition of A. Okay, so the process is very simple. First you need to find A into A transpose, then find its eigenvalues, then eigenvectors. And next you need to find A transpose into A, then find its eigenvalues, then eigenvectors. See, if you know the eigenvalues of A into A transpose, it is easy to derive the eigenvalues of A transpose into A, because whatever you get it here, that will be repeated here. Okay, but suppose if you are given with a square matrix, it is enough to find eigenvalues of just one, A into A transpose. But when it comes to the eigenvectors, you should go for both A into A transpose and as well as A transpose into A. Okay, so once if you get these eigenvectors, you write these matrices. But remember, the columns of the matrix must be unit vectors, and the matrix whatever you write here, that must be an orthogonal matrix. Anyway, you will get orthogonal matrix. Why? Because we know eigenvalues of eigenvectors of a symmetric matrix are orthogonal. We know that, right? Here you can see that A into A transpose, when you take its transpose, this is same as A transpose whole transpose multiplied with A transpose. This is same as A into A transpose. Therefore, A into A transpose is symmetric. And similarly, A transpose into A, this is also symmetric. And we know for a symmetric matrix, if you look at the eigenvectors of a symmetric matrix are orthogonal. So anyway, you will get an orthogonal vectors only. Only thing you need to make their length as 1. It means you find the length and divide with its length. So that's what you have to do. And in place of sigma, you should write the square root of the eigenvalues of A into A transpose. Okay. So singular values of A, suppose if you are asked to find just the singular values of A, which are nothing but square root of eigenvalues of A into A transpose. That's it. So these are the singular values of a matrix A. Okay. So this is how you need to convert a matrix into SVD, like U into sigma into V transpose. Okay, so this is all about SVD. Okay, this video will help you to solve a problem. That's it. Okay, thank you. Bye.